Hi there, I'm Nostradamus. This is going to be a follow-on to my previous video on CO2. Thanks for joining me. If you're new here, then welcome, but please do watch my previous video. It shows you where I'm get all the data from for this video, and it shows a correlation between rises in CO2 in the atmosphere and the El Nino, La Nina oceanic conditions. So in this video I'm going to go into a little bit more detail, go one step further, and there's some quite interesting things to be gleaned from the way I've interpreted the data. The diagram you can see on the screen is a simple depiction of Earth's carbon cycle. The green is estimates of pre-industrial levels, and the red are the recent changes. So all I want to do here is concentrate on the green, which has been in perfect balance since the last ice age until we came along. So if you add the land and the sea, you can see added together 440 and 260 is 700 gigatons of carbon is released annually into the atmosphere, and the same amount, 700 gigatons, was sequestered back into the land and the vegetation and the sea. The recent changes caused by humans are shown in red. So on the left we have the industrial, which was about 26 gigatons per year when this was produced, and this was back in 2004. Now this has grown year by year since then, and we surpassed 36 gigatons per year of carbon dioxide in 2018. But surprisingly, just bear in mind, 36 is just 5% of all the carbon dioxide being released naturally into the atmosphere. We've got 700 gigatons if you add what's coming from the land and sea together. It's just 5%, but it makes a big difference. Now, up until recently, as you can see in the centre of the diagram, we've had an increased uptake by plants of 10 gigatons per year. So, as there's been more CO2 in the atmosphere, then vegetation has been doing very well. And also, the oceans have been absorbing 10 gigatons more than what they've been releasing until recently. Now, the purpose of my calculations, which I'm going to show you, is how well has the planet been doing over time since 1960. And the plan was to do all my calculations and plot a graph at the end of it, not knowing what the graph would look like, and whether or not it would show if there was any deterioration in the planet's ability to absorb carbon dioxide. Basically showing how healthy the planet is over time and whether it's getting worse or not. So here we go. Now this is what I neglected to show you in my previous video, and I left a link to it below in my last one, showing over the past 70 years the El Nino years and the La Nina years, and how strong or weak they were. And what I've done for the purpose of my calculations in this video is I've clumped them into three groups. First, I've clumped the moderate, strong and very strong El Ninos together in one group. I've put the strong and moderate La Ninas in another group, and in the third group I've clumped together the weak El Ninos, the weak La Ninas and all the neutral years all into one. Now I've done much the same as I did in my previous video, but I've done a few additions as well, plus I'm going back all the way to 1960, and I've done it in 20-year intervals from 1960 to 79, 1980 to 99 and 2000 through to 2019. So on the left we have the annual reported carbon dioxide concentration in the atmosphere, rising year on year. I've highlighted the El Nino years in orange and the La Nina years in turquoise, and I've left the neutral and weak years for either oscillation in white, and I've worked out the annual growth rate in parts per million. That's for 1960 to 1979. Over the 20-year period we had a total growth of 20.8 parts per billion, with an average annual growth of 1.04, and I've worked out the average annual increase in El Nino years was 1.43 parts per million, 1.01 in neutral years, and La Nina years, the average annual increase of CO2 parts per million in the atmosphere was just 0.67. I've done exactly the same for the period from 1980 to 1999, where we had a total increase of 31.6 parts per million, which is an average of 1.58 per annum. Now this bit is very interesting and very counterintuitive, because in the El Nino years it went up an average of 1.95. In neutral years it only went up by 1.35, but instead of being the lowest, the La Nina years went up 1.67, which is 0.32 higher than in neutral years, and I can't explain that. It goes against all the other observations that I've made. So now to the most recent period from 2000 to 2019, we had an increase of 43, which is an average of 2.15 parts per million per annum. During the 3 El Nino years, it went up on average 2.8 parts per million. Neutral years, it only went up 2.12, and La Nina years was just 1.75, which you would expect that to be the lowest, not as in the previous 20 years average. Looking at the total 6 decades worth of data over the past 60 years, including 2020, we've had a rise of 95.4 parts per million, an average of 1.59 per annum, 1.98 during El Nino years, 1.53 in neutral, and just 1.4 in La Nina years. I just want to go back to this just for a second. So pre-industrial, there's 700 gigatons going up and 700 gigatons coming down. So it was in balance, and 100% of all carbon dioxide released was being reabsorbed. Now, since we came along, we've been putting more and more into the atmosphere, and the oceans have been doing a pretty good job of absorbing a lot of the human emissions, anthropogenic CO2 produced. And indeed, I think the latest figure is they've absorbed about 30% of all man-made CO2 that's been produced since the beginning of the Industrial Revolution. I want to know how this has this 100% sequestration. How has it changed in recent times, and is it declining due to the extra CO2 we're putting up there? So how do you go about producing a graph that shows the percentage uptake of CO2 in the atmosphere year on year? Well, this is how I did it. I've started off with the annual CO2 concentrations which were reported, and I've adjusted each figure, like I did in my previous video, to as if there was no El Ninos and no La Ninas, and every year was a neutral year. So I've totally taken out the effects of the East and West Pacific sea surface temperatures. And I've taken the data for the anthropogenic annual emissions, and I've added to those the pre-industrial 700 gigatons that are naturally added to the atmosphere from land and sea, which it showed in the diagram. And then I've converted those gigatons into parts per billion. I showed you how to do that in my previous video. Works out 1 part per million of CO2 is equivalent to 7.83 gigatons of carbon dioxide. Next, I've listed the annual increase in CO2 in parts per million of the neutral adjusted figures. Now, before I carry on to the next column, let's just look at 1964, for example, which was the first El Nino year in my calculations. So I adjusted the CO2 levels in the atmosphere down because during an El Nino year we get excess CO2 withheld in the atmosphere. Humans were responsible for 10.8 gigatons. Add that to the naturally 700, get 710.8. Divide that by the 7.83 to convert it to parts per million is 90.8. And the increase over 1963 on the adjusted figures was just 0.2 parts per million, had it been a neutral year. So that 0.2 parts per million is what got left up in the atmosphere more than the previous year. So if 100% of all the carbon dioxide put up in the atmosphere by humans plus natural, then the parts per million sequestered would have been 90.8, but only 90.58. I've only got one decimal place and I've got 2 on this one for a bit more detail. So a difference of 0.22. So 90.58 was taken up by the planet out of 90.8 which was put up. So that comes out that 99.78% of all the atmosphere in that year was sequestered by the Earth, taken back out of the atmosphere, leaving the excess 0.2 parts per million, which shows us the annual increase. Okay, I know it's complicated. I'm trying to explain my calculations as best I can. So I did the same again from 1980 to 1999. I've got a few bits highlighted there, and I'll show you my reasoning for that at the end. And here's my calculations from 2000 to 2019. And as you can see, the percentage uptake has dropped a little. And at the bottom I've added on the figures for last year, 2020, when the official CO2 concentration was 414 parts per million. It's estimated that man-made emissions dropped by a couple of gigatons because of the pandemic, by an approximate 5% on 2019. Add the 700 natural to that, convert the gigatons into parts per million. I've left the annual increase at 2.6 parts per million. I've taken it as a neutral year, or as a weak La Nina, although it may be classed as a bit stronger when the data's officially finally in. So that means 91.2 parts per million was absorbed out of the total release of 93.8, which comes out that 97.23% of all the carbon dioxide released was reabsorbed. So finally, after all those calculations, I can finally plot my graph to show how well the planet's been doing at absorbing CO2 from the atmosphere over land and sea for the past 60 years. And I've put some labels on it too. I think it's very revealing. Now, like I said, I had no idea what the final outcome of what this graph was going to look like by the time I'd finished. And this is the total annual percentage uptake of planetary CO2 for the past 60 years. And we can see that it started to decline even back during the 60s. We had a strong La Nina in 74, I think that was, and the planet did really well that year. We know there's a link. We had a big drop in 1980 when Mount St Helens erupted, and at the beginning of the 90s we had a large increase in percentage uptake, all the way back up to 99.5%. The planet was really healthy then. Just happens that when they banned CFCs and other noxious chemicals that we used to put into the atmosphere. The next sharp decline was in 1998 when we had a strong El Nino, and that was followed by a quick rebound when we had two strong La Ninas in a row in 1999 and 2000. And then we've just had a steady decline ever since, and just to show that we had a drop during the strong El Nino in 2016, but we got as low as 96.75% in 2019. So what does that mean? Well, this does suggest to me that the planet's ability to uptake CO2 is declining. We're cutting down the forests. The forests we are cutting down are burning. The oceans are getting saturated. And of all the stuff we're emitting and putting up there with an ever increasing volume, the more of it's going to stay up there. Not good, folks. I do hope you enjoyed this presentation, and I hope you could follow me reasoning. I'll be back soon with another video, but I've probably finished on this subject for now. Well, thank you all very, very much indeed for watching, and I do appreciate any feedback you may have in the comments. All comments are welcome, as long as they're nice. So, thanks again, and see you all soon. Goodbye.